This is Sound Noise Acoustics Engineering Podcast with Bill Holliday, episode number 11, brought to you by Sound Solutions, an independent acoustical consulting firm at ssacoustical.com. Thank you for joining me on this episode. I'm going to be talking about workplace noise control, evaluating and mitigating noise exposure for workers. So why is soundproofing important, or why is factory noise an issue? A lot of times factories have high ceilings, a lot of hard reflective surfaces. Many times they need to be cleanable so they don't put a lot of absorption up. Large, not a lot of reflections because the volume is so large. And many times there's loud machinery. So noise can be hazardous to health and safety for employees. Employees may not be able to communicate as well, which makes them less efficient, could result in unnecessary accidents, and exposure to extremely loud noise can cause permanent hearing damage. So we're going to look at how that's evaluated and how to mitigate it. But it's an important issue. Computing worker noise exposure. So OSHA, that's the U.S. Department of Labor Occupational Safety and Health Administration, their OSHA Noise Exposure Code states that you can be exposed to different levels depending on the duration of that exposure. So if it's an 8-hour workday, you can't be exposed to more than 90 decibels. If it's a 12-hour workday, that goes down to 87 decibels, and that's dBA. If it's a 6-hour workday, you could get exposed to 92 dB. And if it's just for 1 hour, you can get exposed to 105. So that's just stating that that's the limit. And they're feeling that if you have long-term exposure, that many hours per day, you could get some hearing damage. So what they say is, hey, for an 8-hour work week, we're going to call this the time-weighted average exposure. If it's above 85, then you really need to have attenuation. And if it's and that's equivalent to an 82 for a 12-hour workday. And you need to have some sound attenuation or a program in place. So there's a conversion. There's two ways to deal with or measure the noise exposure. One is you can attach a dosimeter to a worker and just have it track that person for a day or for multiple days and get a feel for what the exposure is, or track different people. And it gives you the sound level meter or dosimeter will show you what that exposure is and how much it eats into that time-weighted average. And it'll come up with, all right, here's an 8-hour time-weighted average. Even though they had, 15 minutes at 110 or 5 minutes at 80, they took a lunch break and it was 60, it'll calculate all that exposure. And I put in the show notes the calculation. You look at this dose is the exposure divided by the amount of time, and it becomes a fraction, and you add all those fractions up at the different levels, and you can calculate the exposure, the total exposure they have. So that's just measuring it. You can determine if they pass or not, if they need that 85, if they need to have some kind of program in place. The other option is to just take some samples in the different areas where people work, estimate how long they spend in each of these areas, and compute yourself what that exposure is. And it's probably best to do both, or the more important one is coming up with what levels are they exposed at for what amount of time, because that's really going to be the most useful to mitigate. And I put in some tables for how to calculate those numbers. As far as noise mitigation, we have 4 strategies we're looking at. Treating the noise source, treating the noise path, treating the noise receiver, or limiting the time in certain areas. And the final treatment, of course, could be a combination of these. So the noise source, we're looking at replacing equipment with quieter equipment with smaller units, Maintenance of equipment. We've gone out many times where belts haven't been replaced, something's not balanced, or lubrication hasn't been done, and that can significantly reduce the noise. Lagging the equipment. A lot of times we'll use loaded vinyl with a quilt on the inside to decouple that loaded vinyl from the equipment. Or enclosing the equipment. Sometimes it can be a hard enclosure with absorption on the inside. Or location of equipment. If you have several pieces of equipment in one area, it could be just isolating the pieces of equipment to keep that environment a little quieter. So that's treating the noise source. The noise path. Here's where we get into a calculation that's pretty useful. So noise propagates by a direct path, that's line of sight, the direct path, and the reverberant path that bounces off of walls in a facility, and that's based on the room coefficient, or the room constant, or the reverberation time, the echoiness of the room, how many walls there are, or how big of a volume it is, and how absorptive those walls are. And I put a formula in here, but when you're looking at the sound pressure level at any one point, you're looking at the distance from the source, that'll be 1, and there's this directivity coefficient, whether there's reflective surfaces near it, a hard floor, hard walls, that'll add in. But basically it's the distance, the further away the quieter, and then there's this echoey, the reverberant element. And the further you are from the noise source, the more that reverberant element will be an issue. The closer you are, the more that direct will be an issue. And this is important to separate. And you can separate them out. You can look at just the distance component. You can look at just the reverberant component. And you can calculate, you can measure that reverberant component by doing a reverberation time measurement, where you play a loud broadband noise source in a room or in this factory room, you turn it off, you measure in each octave band or third octave band how long it takes it to drop 60 decibels. From that you can calculate the room constant, and that'll give you an idea, or you can just model it based on the volume, surface area, types of room finishes, number of people in the room. You can get an estimate for what that room constant is. From that you can calculate this reverberant noise and the direct noise, and it's important to separate those because the mitigation of the path is going to be dependent, or it's only going to affect one of those. So if you put up a barrier, that will affect the direct path. If you put up, but it'll do nothing to the reverberant path. If you put up absorption, baffles, or some kind of absorption behind perf metal, or it could be, lapidaries, or wall absorption. If you put up absorption, that'll have no impact on the direct noise, but it'll impact the reverberant path. So it's important to know what's contributing at what part, in what part of the facility, to be able to determine what's the most important, or what needs to be done to meet the criteria. So a lot of times, if you're getting a lot of exposure but you're not working on a piece of equipment, you might not be able to put a barrier up for a piece of equipment, but you're spending time further away from the noise sources. A lot of times adding absorption of the room will not have much effect when you're working right close to the loud equipment, but it'll limit your exposure during the day and reduce your overall noise exposure, or noise, the noise impact there, the time-weighted average that you have. The third approach is to treat the worker, the receiver, and that's using hearing protection, some kind of booth or shield, right for the worker. And the fourth is to limit your time in certain areas. And that could be adding staff to cut the shifts down. Instead of 12-hour, have 8-hour shifts, or rotate people in loud areas so that you don't have as much exposure in certain areas. So those are the 4 basic strategies. I've put in the formulas for calculating that noise, direct versus indirect, and how to calculate the exposure. If you have any questions, let me know. Next time I'm going to be talking about HUD noise studies. Thank you very much for listening to Sound Noise Acoustics Engineering Podcast. We provide you with knowledge and resources to address acoustical issues. I'm Bill Holliday. This is brought to you by Sound Solutions Acoustical Consulting at ssacoustical.com. If you need acoustical consulting services from acoustical engineers, please contact them at ssacoustical.com. We appreciate your feedback. You can email me, LinkedIn, the website, call. Be happy to provide you with a free proposal, answer any of your questions, whatever you need. All right, thanks a lot.